So for our first example, all we have are two equal fractions, okay? All you have to do with the restriction is look at your denominator, and that cannot be equal to 0. So each individual denominator, you're going to set not equal to 0. And you're going to solve for that x value, and that will be the x value of your restriction. That x value will cause a 0 in the denominator, and that's why you cannot have it. Okay, so if I solve for this x, I would subtract 1. X cannot equal negative 1. Okay, that's my first restriction. And then 4x plus 5 cannot equal 0. I would subtract my 5. 4x cannot equal negative 5. Divide by 4. X cannot equal negative 5/4. That's my second restriction. Okay. Once I do my restriction, then I'm going to see how do I solve this. When I have just two fractions being equal to each other, I don't have to do an LCD. Think about when was the only time you've done an LCD? When you're doing what operation? Adding and subtracting. Okay. So if I have something added or subtracted behind it, then you have to find a common denominator. But if all I have is two equal proportions, then I'm just going to cross multiply. So you will have to be able to identify that and know the difference on your test. Okay. So if I cross multiply, I'm taking 3 times the 4x plus 5, and I set that equal to the 9 times x plus 1. And then from there, it's just an equation. I distribute and then combine like terms. So that's going to give me 12x plus 15 equals 9x plus 9. Now that's a two-step equation. I'm going to get my x's on the left, so subtract my 9x. And then get my constants on the right, subtract your 15. So that leaves me with what? 3x equals negative 6, good. And you're going to divide by 3, x equals what? Negative 2. I compare that to my restrictions. Is that one of my restrictions? No. So this could be my answer. Now remember, when you get x equals a number, what can you do with that? You could check it. You can plug it in and check it. Okay? So if we look at our next section, this is going to be where you don't have just two fractions equal to each other. So you're going to have to do the LCD. Okay, so anytime you have two fractions added or subtracted at any point in your problem, that's when you find a common denominator. Okay, so we still factor what we can. We're still going to do restrictions, and then we're going to find our LCD. And then we're going to multiply the entire equation by that common denominator. Okay, and so the reason that we're going to do that, if you think back to just a normal equation, if I have, let's say, 2/3 x plus 1/4 equals 7/6. If I had that, and you didn't want to work with fractions, you can multiply everything by a number that will cancel out all of those denominators, okay? That would be your common denominator. If I took a 3, a 4, and a 6, my common denominator would be what? 12. So if I took a common denominator and just multiplied by that 12, 12 is the number that will cancel all of those denominators out. And so if I had 12 times 2/3, well, that 3 and 12 would become a 4, and I'd have 2 times 4, which is 8x. And if I had 12 times 1/4, that 4 and 12 would become a 3. 3 times 1 is 3. And then if I had 7/6 times that 12 and 6 would reduce to 2. 2 times 7 is 14. Okay? That is essentially what we're doing, but now with polynomials. Okay? So if we look at our first example, our first one's really simple. You've got 3 over x. plus 8 over 5 equals negative 13 over x. Okay, we check. Can we factor anything? No. So then we need to do our restriction. So anywhere there's an x, you're going to set that as a restriction. See how these x's are repeated? You only have to do it once. There's no point in doing x cannot equal 0 and x cannot equal 0. Okay, so that one x cannot equal 0 is going to account for both of these. Okay, so that's my only restriction. Once I find my restriction, I need to find my LCD. So if I look at my denominators, what could be my common denominator? 5x. Good. Okay, so what I'm going to do is I'm going to take that entire equation and I'm going to multiply it by 5x. Notice I did not do 5x over 5x. That's what you do when you're adding and subtracting. If all I had was this, then we would be multiplying numerator and denominator. I don't do that with complex fractions, and I don't do that with this. Okay, you have to know what your work should look like for each of these three sections when you're adding and subtracting, when you've got complex fractions, and whenever you're solving. Okay, so here, when I multiply by 5x, that's really over a 1, if you really need to consider it that way. Okay, and so what I do when I teach this for the first example is I take each three of these and I actually write out multiplying by 5x. So I'm going to do that for this first example for you to visualize it, and the other three I'm not. Okay, so I'm going to take this 3 over x and I'm going to multiply it by 5x. And you can put it over 1 so you see that that goes to your numerator. Okay, then plus you have your 8/5 times your 5x. Again, if you want to put it over 1, you can. Equals your negative 13 over x times your 5x. Okay, what's going to happen, writing it like this allows you to physically cross stuff out. If you are someone who needs to put the pen to paper and cross it out, then this is how you need to do it. Okay, because what's going to happen is if I look, this x will cancel that x. And what am I left with? 3 times 5, which is 15. Plus, when I take 8/5 times 5x, that 5 cancels, leaving me with 8x. Y'all follow what I'm doing? And then that is equal to, if I have negative 13 over x times 5x, the x cancels. Negative 13 times 5 gives me negative 65. Multiplying by the LCD allows every denominator to cancel, which is what you want. Okay, so we want our denominators to cancel in solving equations. We want it in complex fractions, but you do not want your denominators to cancel when you're just adding and subtracting. So that's the section where you have to be careful. Okay, so now this is just a two-step equation. Subtract your 15. Negative 65 minus 15 is a negative 80. Divide by 8, and x equals negative 10. Is that a restriction? No, so this is my answer. And you could check it if you wanted to. Okay? Do we understand that? Okay. Do we have questions or may you re-explain it? So then my second example, I have 5x over x squared minus 2x equals 7 plus 10 over x minus 2. Okay, my first step, I ask, can I factor anything? I can factor this denominator. It might not factor to the difference of two squares, but I can take out a GCF. And so if I have x squared minus 2x, what would be my GCF? I could take out an x, and that leaves me with x minus 2 equals 7 plus 10 over x minus 2. So now I need to account for my restrictions. Okay, I have an x and an x minus 2. Those two things are being multiplied. I have to account for both of them. So I'm going to say x cannot equal 0. There's no solving for that, so that is one of my restrictions. And I have x minus 2 cannot equal 0. So that means x cannot equal positive 2. And that x cannot equal 2 accounts for both of these x minus 2's. I do not have to repeat it. Okay? So now I need to look, what is my LCD? X times x minus 2. Good. So I'm going to take the entire equation and multiply it by x times x minus 2. Okay? Now, I'm not going to write it like I did right here. We are just going to walk through it together, okay? So all I do is look at my first fraction. What happens?
The x.
The whole thing cancels, leaving me with just 5x. Okay? Now, with this 7, does it have a denominator to cancel? No. So it just gets multiplied by the x and the x minus 2. So that just becomes 7x times x minus 2. A common mistake is doing nothing with that 7 and just carrying it down. But if you are multiplying this to all the terms, that 7 takes on that LCD. Okay? And then when I do the 10 over x minus 2, what happens with that? The x minus 2 cancels, leaving me with 10 times x. So 10x. Do you understand that? So then all I'm going to do is simplify. 7x times x minus 2 gives me 7x squared minus 14x. Then I have the plus 10x. Okay? So I can combine negative 14x plus 10x, and what does that give me? Negative 4x. Okay? I've got a 5x equals 7x squared minus 4x. What do you think I'm going to do with that? Anytime you have an x squared term, what are you typically going to do? You're going to typically factor it, so I need it in standard form. Okay? So I need to move that 5x over by subtracting. And that leaves me with 7x squared. Negative 4 minus 5 is a negative 9x, and that is equal to 0. Okay? Now, usually when this happens, we have a trinomial that we need to factor. I don't have a trinomial here. I have a binomial. If it's not the difference of two squares, what do I do with this? This was not the difference of two squares. What did we do with this? We took out a GCF. So look at this. 7x squared minus 9x. Can you take out a GCF? Yes. So if you don't have a full trinomial and it's not the difference of two squares, then more than likely you have to do a GCF. So I'm going to take out an x, and that leaves me with 7x minus 9 equals 0. Okay? So when I set x equal to 0 and 7x minus 9 equal to 0, that x equals 0 is one of my restrictions. So I mark through it. I can't use that if it's a restriction. Then this 7x minus 9 equals 0 is going to end up giving me x equals what? 9 over 7. I'm good with that one. It is not a restriction. Okay? We understand that? All right, we get to move on. All right. The next one is x plus 1 over 3x minus 6 equals 5x over 6 plus 1 over x minus 2. What do I do?
Do you have a class second period tomorrow?
Mm-mm.
Okay.
Factor out the GCF here. If you didn't catch that. So x plus 1 over, what is this going to turn into?
Oh, 3 and then x.
Mm-hmm. And then the rest of it stays as is. So if you don't factor, it will affect your LCD. Okay? So my restrictions, x minus 2 cannot equal 0, x cannot equal 2. I don't do anything with the 6, I don't do anything with the 3 because those don't have x's. Okay? So now I want you to look at those denominators. What is going to be your LCD? 6 times x minus 2. So the x minus 2 is already common, and then between 3 and 6, my common denominator would be the 6. Okay? Do we all understand how we get that? So now we're going to multiply the entire equation by 6 times x minus 2. Now you have to be careful with this first one. Okay? We see that the x minus 2 cancels, but what happens with the 6 and 3? It's just going to leave me with what? A 2, right? If you need to see 6 as 2 times 3, then you can see that x minus 2 cancels, the 3 cancels, leaving me with a 2. Okay? So that's going to be 2 times x plus 1 equals, when I look at 5x over 6, the 6 is going to cancel, leaving me with 5x times x minus 2. And then the x minus 2 on the last fraction will cancel, leaving me with 6. You understand that? So then we just distribute 2x plus 2 equals 5x squared minus 10x plus 6. And then what do I do? I get it equal to 0, so I'm going to subtract my 2x and subtract my 2, so 5x squared. Negative 10x minus 2x is going to be a negative 12x, and then 6 minus 2 is 4, equal to 0. Now how do I factor that? Multiply 5 times 4, so factors of 20 to give me 12. 2 and 10, and they're both negative, right? And what do I do with that negative 2 and negative 10? So that says negative 2 over 5, and then negative 10 over 5 is a negative 2 over 1. Put your x in both denominators, so that turns into 5x minus 2 and x minus 2 equals 0. So if 5x minus 2 equals 0 and x minus 2 equals 0, that gives me what two x values?
2x equals 2 over 5 and x equals 2.
Okay. Are they both my answer?
No.
No. Which one's my answer? The 2 I have to mark through. Make sure you mark through it. You marking through it tells me you understand it's a restriction. If you don't mark through it, it's a point off because you're not comparing that, okay? Okay, so this last example in this section, if you have 7 over x minus 1 plus x plus 5 over x plus 6 equals 7 over x squared plus 5x minus 6. Now, I have a very small area to write. I'm sure y'all do too, so I would not write super large on this one. Okay. Now, what is my first step?
Factor.
Factor. So x squared plus 5x minus 6. What is that going to factor to? X plus 6, x minus 1. Okay. Next, I need to do my restrictions. X minus 1 cannot equal 0, so x cannot equal 1. X plus 6 cannot equal 0, so x cannot equal negative 6. What's my LCD going to be? X plus 6, x minus 1. I'm squeezing it right there, but that should be x plus 6 times x minus 1. And so I'm going to multiply the entire equation by that x plus 6 and x minus 1. I wrote it sideways. Just spin it how you can. Okay. So when I multiply, what's going to happen with my first fraction? X minus 1 cancels, leaving me with good. And then my second fraction, what's going to happen? X plus 6 cancels, so I have my x plus 5 times the x minus 1 that's left equals, what's going to happen for this last fraction? They both cancel, so I'm just left with 7. Okay, so I'm going to multiply 7 times x plus 6 to get 7x plus 42. Plus, when I FOIL x plus 5 times x minus 1, what trinomial does that give me? X squared plus 4x minus 5, good, equals 7. So now I need to combine like terms and get it in standard form all in one. So I've got x squared, 7x plus 4x is going to give me 11x. 42 minus 5 gives me what? And then subtract your 7. So that's going to equal 0. Y'all follow what I did? All right, factors of 30 to give me 11. So x plus 5, x plus 6 equals 0. That's going to give me x equals what? And x equals, what do I know? X equals negative 5 will work, but the negative 6 will not. Okay? Do we understand solving? Do we have questions? Okay. All right. Yes. So, this year we're not gonna do them.